So let's quickly discuss the quiz solutions and we'll move on to the lecture. All right. So which one of the following languages over the alphabet 01 is described by the regular expression? This one. So it is quite simple. Let me show it. So any language, when it asks you, when it has strings like minimum 2 symbols, 3 symbols of whatever character, all you need to do is say, in the previous example, you need 2 zeros, right? Now, it does not say whether these 2 zeros should be together or apart or in the beginning or at the end. No. So every possibility you need to cover, right? So these 2 zeros may be together or may be apart. So there may be a string or may not be a string between them. And that string can be of any type. So any arbitrary string, to represent that, you use sigma star, right? And it also does not tell us that the first zero should be at the beginning of the string. So there may be some random string before this first zero. So you use sigma star there also. And it also does not tell us that the second zero is at the end of the string. So there may be some arbitrary string after the second zero. So there also you use sigma star. Okay. So minimum 2 zeros. That's the only condition. They can come in any fashion, in any way. They may be together, they may be apart, they may be in the beginning, they may be at the end. It doesn't matter. So all those possibilities will be covered by this. Okay. So the answer is the set of all strings containing at least 2 zeros. Then select all the false statements. Yeah, so let's go one by one. Every NFA is also a DFA? No. Right? Because NFA will have epsilon transitions. NFA can have more than one transition for a particular label. That is all not possible in DFA. So NFA is not DFA. The class of regular languages is not closed under the star operation. That is also false. We saw the third theorem. They are closed under all 3 regular operations, right? Including star operation. And a DFA can have only one epsilon transition for each state. This is false because DFA cannot have epsilon transition at all. So this is false. Every DFA is also an NFA. This is true because one can think of every DFA as an NFA with only one parallel branch or one branch, one simulation. And also DFA satisfies all the conditions of NFA. 0 or 1 or more outgoing transitions for a given label. In this case, there will be only one outgoing transition for each label. So that is satisfying NFA's definition. You may or may not have epsilon transitions. There won't be any epsilon transitions in DFA. That is also satisfying NFA's definition. And so on, right? So every DFA is also an NFA. And is NFA more powerful than its equivalent DFA? No, I mentioned it many times. NFA is not more powerful than its equivalent DFA. It is only more convenient. That's all. Both are equally powerful. Okay. The string 1101 does not belong to the set represented by. It's a simple way. You just check. You take each possibility and check if 1101 can be represented by any of them. Like the first one can represent 1101 because 0 union 1 star can be completely deleted. It can come 0 or more times. So you take it 0 times. You are anyway left with 1101 in the first case. In the second case, 110 star 0 union 1. So in 0 star you take 0 one time, and in 0 union 1 you take 1. You will again get 1101. The remaining option is the third option. So that is one way of selecting it. Okay. No matter how much you try with the third option, you can't construct 1101. 0 or 1. So one letter will come in that position. It can be either 0 or 1. No, both of them can't be together. Any language L that can be built over sigma is a subset of which of the following? This I mentioned many times. Any language that can be built over sigma is a subset of sigma star, because sigma star is the universal language over sigma. Every possible string that you can construct over sigma will be a part of sigma star. So any language will be a subset of sigma star over sigma. Why not the fourth option? Sigma power k, where k greater than or equal to 0. K can be as high as you want. Exactly. It is 1K. Sigma star is union of all Ks. Sigma power 0, union sigma power 1, union sigma square, and so on. This is only 1K. So it will be either sigma power 1 or sigma square or sigma power 100, whatever it is, only one particular sigma power. But we want union of all this. So if only the fourth option were slightly changed to union of sigma power K, where K greater than or equal to 0, that will be equivalent to sigma star. So that is another way of representing sigma star. Okay. Select all the strings accepted by this FSM. Quite straightforward. Take each string and see whether it ends in a final state or not. That's it. So I won't spend much time on it. Consider the regular expression, this one, 0 union 1, 0 union 1, and so on n times. The minimum number of states, including the dead and unreachable states in the DFA that recognizes this language is. So any language, if it has, say, strings of fixed length, and if the string length is, say, n, then you will need basically minimally n plus 1 states plus the dead state. Okay. Why n plus 1 states? You just take, say, a language with strings of only length 2. So maybe AA, AB, or whatever. Or let's just take a language which accepts only AB. Okay. So the machine will have start state. On reading A, it goes to the next state. On reading B, it goes to the next state, and this will be the final state. But you can leave at this if this were NFA. This is not NFA. This is DFA. So you have to have a dead state, and the first state on getting a B, it should go to dead state. Second state on getting an A, it should go to dead state. And third state on getting either A or B, it should go to dead state. And again, dead state should have a self loop. Okay. But if you sort of ignore this part, for a string of length n, you will need n plus 1 states. Straight one for each character, you need a state. Add start state to that. So n characters, n states plus 1 start state, n plus 1 states. But since this is DFA, if you are asked to include dead state also, it will be n plus 2. If you are asked to exclude dead state, it will be n plus 1 only. Okay. Here, I asked including dead and unreachable states. There are no unreachable states here. Only dead state is there. So n plus 2. Okay. Minimum n plus 2 states you need to capture a string of length n. Okay. And what is E of delta of Q1 comma 1 for the below automaton? Okay. So Q1 comma 1 will be Q1 and Q2, right? So let me write it down. So E of delta of Q1 comma 1 will be E of Q1 comma Q2, and that will be E of Q1 union E of Q2. Okay. What is E of Q1? All those states which you can reach from Q1 through 0 or more epsilon transitions. So from Q1 there are no epsilon transitions. So through 0 epsilon transitions you can reach Q1 only. So E of Q1 will be Q1. And E of Q2 will be Q2 comma Q3. You can reach Q2 through 0 epsilon transitions. You can reach Q3 through 1 epsilon transition, and no more epsilon transitions after that. So E of Q2 will be Q2 comma Q3. So the answer is Q1, Q2, Q3. Okay. This example is slightly different from the one we discussed in the class. The one we discussed in the class did not have this transition, did not have self loop. So their answer was only Q2, Q3. Here there is a self loop, so answer is Q1, Q2, Q3. Okay. Yeah. So if L1 is A power n and L2 is B power n, consider the below statements. Basically, L1 is nothing but A star. L2 is nothing but B star. All right. So L1 has strings like epsilon, A, AA, AAA, 4As, 5As, and so on. L2 has strings like epsilon, B, BB, 3Bs, 4Bs, 5Bs, and so on. Okay. Both are regular languages. Now L1.L2 will be obviously a regular language because concatenation of two regular languages will give a regular language. So first statement is true. Second statement, L1.L2 is A power n, B power n. Is it correct? Why?
Because
right.
Two A's and two B's. It can't have one A and two B.
Exactly. So when you have like this, A power n, B power n, it is assuming that number of A's and number of B's have to be same. Like 2 A's, 2 B's, 3 A's, 3 B's, 100 A's, 100 B's. It does not accept strings like, it does not include strings like maybe 1A, 10 B's or 10 A's, 1 B. It does not include strings like that. But such strings are actually included when you actually concatenate L1 and L2, right? Because L1 has all kinds of lengths of A's, L2 has all kinds of lengths of A's. So every string here will be concatenated with every string there. So one length string here will be concatenated with one length, two lengths, three length, all kinds of strings there. So you will have A of any length and B's of any length. So this is actually A star, B star. L1.L2 is not A power n, B power n, it is A star, B star. Okay. If you want to sort of capture that in terms of n, then you should not write A power n, B power n. You have to write A power n, B power n. You have to use two different variables. You can't use the same variable. Okay. So A power n, B power n, where mn greater than or equal to 0 is same as A star, B star. Whereas A power n, B power n is not same as A star, B star. Okay. It is a subset of A star, B star. So answer is only one. Let L be the language represented by the regular expression 0011 sigma star over sigma equal to 01. What is the minimum number of states, ignoring the dead and unreachable states in a DFA that recognizes L? Again, now you have 4 characters. You will need minimum 5 states plus 1 dead state. Here you are asked to ignore dead and unreachable states. So the answer is 5. Okay. In the previous case, you were explicitly asked to include dead state. Here you are explicitly asked to exclude dead state. That's the only difference. Okay. Let S and T be languages over sigma equal to AB, represented by the regular expressions A union B star whole star and A union B star respectively. Which of the following is true? So S is A union B star whole star and T is A union B whole star. Basically, both are sigma star. You see, suppose sigma equal to AB, then sigma star will be AB star. Another way of writing it is A union B whole star. So A union B whole star is another way of writing sigma star. This is also same as writing A star, B star, whole star. Okay. Now A union B whole star basically says you have one place and either A or B can come there, but this entire thing can be repeated 0 or more times. So every possible string can come in this. Okay. Now A union B star whole star is again you have one place in which A can come or B can come 0 or more times, and this entire thing can come 0 or more times. Okay. This will also give a sigma star because basically star operation, whether you give it once or twice or 10 times, it will still mean the same thing, 0 or more times. So B star is the same as B star whole star. So it doesn't really make a difference of how many times you perform star over an already starred one. Okay. So here you can think of this as, okay, A union B, entire thing can come 0 or more times. And then A union B star, entire thing can come 0 or more times. The only difference between previous case and now is, in the previous case, B within the brackets should come one time, but overall it can come 0 or more times. So the within the brackets one time is nullified of the outside star. Okay. Now in A union B whole star, within the bracket itself it is 0 or more times, and even outside star also it is saying 0 or more times. So finally it can come 0 or more times. That's all. So whatever strings can come or can be represented using A union B whole star, same set of strings can be represented using A union B star whole star. If this outside star were not there, then A union B is different from A union B star. But since outside star is there, both became equal. Okay, so I can explain only this much. You have to put some thought and think. You have to reflect a bit to understand what I said. Okay, the more I explain this, the more confused you will be. So in case you have any other doubt, come back to me. Okay, which of the following regular expressions represents the language L over sigma equal to AB with two consecutive A's and two consecutive B's, although the pairs of A's and B's can be together or apart and can come in any order. Okay, so basically this is very similar to the first question where you need to have two or more zeros in your language. All right, here the only thing is you need to have AA and BB in your language. The order does not matter, and it also does not matter whether they come together or whether they come apart. Okay, so suppose let's first take the case of AA coming before BB. Now again, they may come together or they may come apart, which means there may or may not be any string, any arbitrary string between them. So you need to have sigma star between, and it's also not necessary that AA should come in the beginning. It can come in between also. So before AA also there can be some arbitrary string, and also BB need not come at the end, or it may come at the end. So after BB also there may be some arbitrary string at the end. So this is one case where AA comes before BB. The other case is BB comes before AA. So BB and AA, and fill the gaps, the neighboring gaps with sigma star. That's all. Now only thing you need to do is take common the sigma star is common. So erase it here. And this sigma star is common. So erase it here. This is the answer. Okay. Clear? So anytime if you are asked minimum 2 or 3 or 10, whatever they are, suppose if I ask you, okay, it should have say 001 as a subsequence, not a substring, but a subsequence. Then you just write 001 and fill all the gaps with sigma star. That's all. But if you are asked to have 001 as a substring, then you cannot have anything between these symbols. They have to come together, and you just fill the beginning and ending with sigma star. Okay. So if it's a substring or a subsequence, based on that, you need to decide. What are the reachable states in this machine for string 001? So on 0, from Q1 you go to Q1 only. Again on second 0 from Q1 you go to Q1 only. On 1 from Q1 you go to Q2. But on epsilon you go to Q3, which means even without reading any symbol you can go to Q3. The moment you enter Q2 you are also getting Q3 for free. So on 001 you enter Q1, Q2 and Q3. So all these three are reachable on string 001. Okay. Fine. What is the length of the shortest string accepted by this machine? 1 1. Minimum string 1 1. So the length is 2. Okay. It cannot accept any string smaller than that. Basically, this is a machine which accepts a language which has either 1 1 or 101 as substrings. That's all. 1 1 is the smallest substring and smaller length, so minimum 2. What is the language recognized by this finite automaton? So this question is slightly, actually, it should be rephrased a little bit. It's not the entire language. Which of these options will be true for this finite automaton? Because this finite automaton does not accept 3 consecutive ones, that is fine, but it does not accept even 3 ones, even a string with 3 ones. So they need not even be consecutive. There should not be 3 ones at all. Okay, so the strings which have 3 consecutive ones, they are not being accepted. They are a substring, they are a subset of the entire language that is not accepted by this. Okay, so the question needs to be slightly reframed, but this will still hold true. This diagram will hold true. Okay. Is the following statement true or false? Sigma sigma whole star is equivalent to the language where each string is of even length. Quite simple. Sigma indicates any character from the set, from the alphabet set. Another sigma indicates again any character from the alphabet set. So two sigmas indicate some two characters from the alphabet set. Now this entire thing you do whole star. So this pair can come 0 or more times, which means you will always have an even length string. That's all. So suppose if I ask you to construct, or what is the regular expression for the language which has or which accepts which has strings of only length 4. What will be the regular expression for that language? Huh? That's it. Sigma power 4. So sigma, 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 sigma. 4 times you write sigma. That will represent all the strings of length 4. That's what sigma power 4 is, right? Sigma power 4 is the set of all the strings of length 4 over sigma. Like that. So this is basically sigma square whole star. Set of all strings of length 2 whole star. So any of those strings, they can come either 0 times or more than once. They are being concatenated with some other strings of the same set. But whatever string you take from that set, it will be of length 2. So it will always be a multiple of 2. So the total length will be even. That's all. What is the language recognized by this FSM? A star, B star. Quite straightforward. The last one is a dead state. Okay. Given sigma equal to 0, 1, select all the true statements. Now, first one is true because sigma cube is the set of all the strings of length 3. 0, 0, 1 is of length 3, so that will belong to sigma cube. Why is the second one false? Right, it should be belongs to. It is not a set. Only if it is a set, it will be subset of sigma star, but it is not a set, it's also a string. So it should be belongs to. And third one is true because 0 plus 1 plus is not a string, it is a set. It is a language. It is an entire language that is a set of strings. So since it is a set, it can be a subset of sigma star. And anyway, any language over sigma is a subset of sigma star. So 0 plus 1 plus is a subset of sigma star. It does not belong to sigma star. It will be a subset of sigma star. So previous one is one string, whereas next one is a set of strings. Okay. So these are the minor differences which you need to know, because we are dealing with mathematics. We have to be accurate, exact in the symbols we are using. Okay. You can't say, sir, only belongs to instead of subset. So please give marks. It won't work like that. Computer won't listen if you try to program this, right? So same thing. And again, fourth one, sigma belonging to sigma star, that is also false because sigma is a set. Yeah. Now, next question is, if I write, is sigma subset of sigma star, will that be correct? Technically, no, because sigma is a set of characters. Sigma star is a set of strings. This we discussed earlier also. Why does epsilon not belong to sigma? Because epsilon is a string and sigma is a set of characters. So I told you earlier also, if you have A, if you put in single quotes, it's a character, but if you put in double quotes, it's a string. So sigma is a set of such characters, whereas L is a set of such strings. It can be A, AB, whatever. All right. So this character A will not belong to L. Similarly, the string A will not belong to sigma. Okay. So sigma star will have strings like this. It does not have characters like this. So this cannot be a subset of sigma star. All right. So this distinction needs to be kept in mind when you're dealing. That's why we don't say sigma is a language over sigma. We don't say that. Sigma is alphabet set. That's it. If sigma can be a subset of sigma star, we can also say sigma is a language over sigma, right? Language with single character strings. But we don't say that. Sigma is alphabet set. That's it. L with single character sigma power 1 is different from sigma. Okay, so these are minute differences which you need to keep in mind. You have to say false. Yeah. Okay. How many substrings of different lengths, non-zero lengths, can be formed from a character string of length n? So let's take an example of say ABC, three character length string. Now number of strings of length 1 will be 3. Number of strings of length 2, AB and BC. So 2 strings of length 2. Number of strings of length 3 will be the entire thing, that is 1. Okay, so that's it. So whenever you have an n character string, number of strings of length 1 will be n, number of strings of length 2 will be n minus 1, number of strings of length 3 will be n minus 2, and so on up to 1. So it is nothing but the sum of 1 plus 2 plus 3 up to n. So that is n into n plus 1 by 2. Okay, so here you are asked for number of substrings. You are not asked for subsequences. So you can't count AC and say that is also plus 1. AC cannot be counted because it's a subsequence, not a substring. You are asked only for substrings. If an NFA has n states, how many states can its equivalent DFA have at maximum? This we discussed in last class also. The states of DFA is nothing but the power set of Q, where Q is the set of states of NFA. And if Q has n states, then power set of Q will have 2 power n states. That's it. Okay, so maximum 2 power n. And this is NFA. Okay, so this is updated. So you anyway got marks for that. All right, so let's continue with the lecture. Any doubts? Any other doubts in the quiz? Okay. So today we'll start the last topic in the first chapter, that is regular expressions. We sort of used and dealt with regular expressions already. Even if you see in the quiz, there are many questions on regular expressions. That is because I already introduced them informally to you already. Now we will discuss them a bit formally. That's all. But you know the idea of regular expressions already. Okay. So again, giving an analogy with mathematics. In maths, we have arithmetic operations like addition, subtraction, multiplication, division, which help us build arithmetic expressions like maybe 3 plus 5 times 6, right? And each of these arithmetic expressions has a value. So what is the value of this expression? Huh? 33. Okay. In the same way, for regular languages, we have regular operations like union, concatenation, and star operation, which help us build regular expressions. Like say 0 union 1, zero star. Okay, and each of these regular expressions also has a value. So what will be the value of this regular expression? Yeah, it's a language. So each regular expression represents a language. So the value of a regular expression is nothing but the language which it represents. Okay. So it's a regular language. All right. So this particular regular expression represents what language? Yeah. I mean, just you can describe it in words. Nothing. It starts with a 0 or 1 followed by 0 or more zeros. Quite straightforward. Yes. Vice versa. Yeah. So omega starts with a 0 or 1 followed by 0 or more zeros. Now you should get a doubt. What do you mean by 0 union 1? Union is a set operation. How do we perform union of a character or a string 0 and 1? Yeah, what does it mean? Fine, but it can't be just or in that sense is okay, but some mathematical meaning should be there. What you're saying is more like an informal meaning. Huh? An element from the set 0 union 1. Okay. Yeah, you're all telling me the informal meaning. The question is, how can you perform union on a string or a character, whereas union is a set operation? Set of single character. Exactly. Basically, it's a set of single string with one character. So here, each one is not a character, not a string. It is basically a regular expression. And a regular expression stands for a language. Okay. So this complex regular expression is made up of simpler regular expressions. 0 is a regular expression, 1 is a regular expression. And 0 as a regular expression stands for the language which is a set of one string that is 0. And 1 stands for a language with one string that is 1. So you are performing the union of two languages and concatenating it with another language 0 star. Okay, so let me mention that. Zero union 1 concatenated with 0 star is a shorthand for 0 union 1 concatenated with 0 star. Okay, so we are still dealing with sets only. We are not dealing with direct strings or direct characters. We are dealing with sets of strings. We are performing union of sets of strings. We are performing concatenation of sets of strings. Okay, so there's nothing problematic here. All right. Okay, let's continue. Formal definition of a regular expression. Okay. R is a regular expression if R is one of the following. There are 6 conditions to say what is a regular expression and how to construct a complex regular expression from a simpler regular expression. So the first 3 conditions are primitive conditions. That is, when you use a single character like A, that indicates a regular expression for some for some A in the alphabet sigma. I will show in a minute the equivalent set representation of each of these regular expressions. Second one, epsilon. So empty string is also a regular expression which denotes a set with empty string. Okay. And third, null set. This is also a regular expression. So this can be used both as a set and also as a regular expression. And so the first 3 are primitive regular expressions. The next 3 are combinations of regular expressions to form a larger regular expression. So R1 union R2, where R1 and R2 are regular expressions. Similarly, R1 dot R2, again where R1 and R2 are regular expressions. Finally, R1 star, where R1 is a regular expression. Okay. So basically, each of these regular expressions represents or describes a regular language. So let's look at the regular expression and the corresponding regular language. So A represents a regular language with a single string A. Epsilon represents a regular language with a single empty string. Okay. And null set represents a regular language with no strings. I hope by now you know the difference between these two. A language with an empty string is different from a language with no strings at all. Okay, both are not same. All right. And here also you can think of powers of R like R power k, that is R concatenated with R k times. Sorry. Yes, epsilon here indicates a language with empty string. Null set, a language with no strings, not even an empty string. Yeah. Like, how do you draw an automaton which accepts only empty string? And how do you draw an automaton which does not accept any string, not even empty string? Yeah, so you have a start state. If it is also an accept state, it accepts only epsilon. That's it. And in case you have any other symbol, say maybe if the alphabet set is AB, so if you get anything else, you go to a dead state. Okay, and you remain in the dead state. So this accepts only epsilon. It does not accept any other string. Now, if I don't want to accept even that, all I need to do is to make this final state as a non-final state. That's it. So this machine will not accept any string. Okay, quite simple. So both are different machines and both are different languages. Got it? All right. And here also we can speak of R plus, that is R power 1 union R square union R cube and so on. And R star, that is epsilon union R power 1 union R square and so on. Okay. And R star can also be written as R plus union epsilon, or you can also write R plus as, in terms of R star, how do you write? Without using epsilon, huh? In terms of R star. Yeah. R star. It's like A plus is nothing but A star. Same thing. It can neatly be sort of transported to any other domain, whether you're dealing with individual characters or you're dealing with sets or you're dealing with regular expressions. The equations remain the same. A plus is A star, and maybe sigma plus is sigma star. R plus is R star. Everything is same. Okay. All right. If R is a regular expression, R star R will be different because, again, I need to get into infinities. So I'll just leave it here. Say infinity plus 2 is not the same as 2 plus infinity. In infinite numbers, addition is not commutative, multiplication is not commutative, it is different. Why? Because how is addition performed? Finally, you need to boil down everything to the fundamentals. So when you perform 2 plus infinity, what are you doing? Say you have some two objects, and then you are placing infinite objects beside these two objects. Okay. So you are counting, okay, 1, 2, 3, 4, 5, and so on up to infinity you will go. But if you are first putting infinite objects and then you are putting two objects, what will happen? So you are first placing infinite objects, all right, and somewhere you want to place these two, but you will never reach there. So if you start counting 1, 2, 3, 4, and so on, you have counted infinity and you will never reach 2. So infinity plus 2 is infinity plus 2, whereas 2 plus infinity is infinity. Both are different. Same thing here. Okay. Yeah, if R is a regular expression, its corresponding language. So even in R star R case, same thing will happen. So if I have to write R star, what is that? R power 0, union R power 1, union R square, and so on. After finishing all these, I should come to R, but this will never happen. But if I start with R and then R star R union R power 0, union R power 1, and so on. So this can be done, whereas this cannot be done. And this will be equal to something else. Okay, so both are not same. If R is a regular expression, its corresponding language is represented as L of R. Okay, all right. Now let's look at a couple of identity operations. So in maths, you know what an identity element is? What is an identity element? Yeah. So what is the identity element for addition in numbers? 0. N plus 0 will give you n only. What is the identity element for multiplication? 1. N into 1 will give you n only, right? Now similarly, in regular operations also, we have identity elements and the operations you perform with them are identity operations. So what is the identity regular expression for union? Yeah, it's null set. You perform union of any set with null set, you will get back the same set, right? So R union null set is R. What is the identity element for concatenation? Epsilon. You concatenate any string with epsilon, you will get back the same string, right? So you concatenate any set with epsilon, you will get back the same set. Or you concatenate any regular expression with epsilon, you will get back the same regular expression. Okay. Now, what if I exchange phi and epsilon in the above operations? What will happen? What will be R union epsilon and R dot phi? Phi is not? Phi is not a string, but it's a regular expression which represents an empty set. R union epsilon need not give us R. What will it give?
A set of R including epsilon.
Yeah. And R dot phi? What will R dot phi be? Phi. Why?
There's no common in between them. So they represent no, but you can't concatenate to anything because it's fine.
Yeah, answer is phi. R dot phi is phi because concatenation operation itself cannot be performed. So the result will be empty. So the result will also be an empty set. Okay. So um, So let me quickly take an example. R union epsilon is not the same as R. So if I take say 0 union epsilon, that is 0 union set with epsilon, that is 0 comma epsilon, it is not equal to the beginning set 0. Okay. So this is R union epsilon. It is equivalent to R union set epsilon, and it is not same as R. And finally, R dot phi equal to phi. Okay. So I'll elaborate this in the next class. This is not the same as R. So in both cases, you will not get back R. You will get something different. Okay. So they are not identity operations. They are not identity elements for these operations. They are identity elements for the other operations in the previous case. Okay. So let's stop here.